All right. Hi, everybody. Sorry for adding these the Canvas late. There's been some unexpected family challenges, and um, we all just have to sort of work in these spaces. And so I'm coming to you now with Chapter 4, Research Methods. Thankfully, it's a shorter chapter, so you shouldn't it shouldn't be something that you struggle with a little bit. Struggle with you. It shouldn't be something that you struggle with too much. Um, Make sure it's charging. Excuse me. Okay, here we go. Okay, so beginning this chapter, basically began with a review of some of the basic elements of the scientific method. Okay, and so this first, we're beginning with empiricism. And this is the idea that all knowledge comes from our senses of the natural world. And this begins with observation. So we are, as human beings, sort of like sensory processing systems. And so in this basic sense, everything that we know comes through our senses, of whatever natural world that we in, and that's the reality that our brain creates. That's where all knowledge comes from. That's how we get this information. So right now, we don't have any way of implanting, knowledge or skills like they did in the Matrix, or a number of other things. And so it all comes from observation. So the scientific method is very much based on this, and that this idea that in our observation, we should be systematic and things like that. Hey, no, my dog, sorry. So in that sense, it begins with a hypothesis. And this is a hypothesis, and as you've seen in research methods, or you will soon too, is a statement of prediction of how something in nature actually works. So kids can come up with hypotheses, of anything about like how do things work and stuff like that. But then in the scientific method, we come up with a specific hypothesis. It has to be a directional statement. I think blank will have this type of effect, not just an effect, but a specific type of effect, increasing or decreasing on, on the outcome variable. So the independent variable and the dependent variable is what we then come to in terms of testing hypotheses using experimentation. All right, so I think our little man is only going to be satisfied with that, with being on during the lecture. So so we basically, hypothesis comes from our observations, and it is testable, and we test these hypotheses through experimentation. And in experimentation, then we have this independent variable, which is the manipulation. So it could be physical activity, it could be brushing your teeth, it could be whatever, whatever sort of piece that you're doing. And then you measure that on, on a dependent variable. This is, like how the amount of plaque on your teeth, increases in physical health. And to do really proper experimentation, then you're going to have control groups where you're going to compare a treatment group and a control group to actually come up with effects. Then you can also have double-blind research, which is when an experiment is being conducted and the participants are blind. They don't know which condition they're in, meaning a control condition or a treatment condition, for example. And the experimenters do not know what condition they're in. So the experimenter who's running the study does not know whether this person is in a control group or a treatment group. And that makes sure that that's like trying to think that, okay, all these observations that this method begins upon, then those, we're not trying to build in any biases when we build in the experiments, that even the people running the experiments don't often know what groups the participants are in. And this helps keep the research more clean and less and free of bias. So double-blind research is kind of the best option. It's not always possible with all types of research, but there's but they are there are very specific sort of ways to conduct well-designed experiments, control groups, double-blind research, looking at your sample size, your, where your population is, that are really important for drawing valid conclusions about some data that you're observing and to test your hypothesis. And then through experimentation, we can test these things by quantifying what we are seeing through, it could be qualitative variables, where we're looking at personal responses, or quantitative variables where we're looking at, say, a person's score on some sort of questionnaire. And then what we use is we use these results to develop theory, and then, if you have good theories, they actually come up with new questions and new testable hypotheses that can then, of course, continue to broaden that area of research, and would drive replication studies where you would actually repeat the experiment to see if you got the same result. And then also conducting meta-analyses where you would be trying to look at research that is all similar in one way, and then saying, okay, across all of these studies, examining sad emotions during purchases, just something, then we find this element of, we find this consistent finding in the research. So that tries to go through and identify specific overarching patterns that have developed after many, after multiple replication studies and things like that. Oh my goodness. Sorry, that's my dog, Benny. All right. Quiet. And then we've got animals in research. And I'll probably finish this slide and then I'll have to let Benny upstairs. So animals in research, we take this general process approach. And this general process approach is basically these fundamental principles of genetics, physiology, learning, and neuroscience. They're all similar across species of animals. So that even if you look, when we get to the developmental chapter, you'll see like even a high degree of embryonic similarity across all different sorts of animals and species, similar like for mammals and humans in terms of like embryonic development, and then at key particular places it differentiates. So there are certain similar processes in terms of genetics, physiology, how learning occurs, how animals and people react similarly in certain situations, and neuroscience in terms of the way neurons function across species for similar types of behavior. These are all ways that we can learn about how information processing occurs, whether it's for humans or for animals. In terms of psychological research, rodents and pigeons are used the most, and these are this is really oftentimes to test learning capacity and for reactions in particular situations. Rodents, for example, have been, they are highly trainable. They have memory and hippocampi similar in shape and structure to humans. They can learn sort of complex tasks and things like that. So we can actually learn a lot about neuroscience, physiology, how genetics, change over time in rodents, because they also, they replicate so quickly. And and then we can also have particular procedures that we use to determine even more information about the genetics, physiology, learning, and neuroscience. And these include modifications to our rodent friends. One of them would be called a transgenic mice. And this would be where a gene is inserted into the into at a particular time in development, and then they see how this inserted gene can affect downstream development, learning, and so on. So this can be used to test hypotheses about the genetic underpinnings of certain diseases and learning, decision-making, mood regulation. And then we also have knockout mice, and this is where a gene is made inactive. And you can also then see how, if you have a hypothesis about the role of a certain gene in learning physiology, genetics, mood regulation, all sorts of, these above behaviors, then you can kind of knock out that gene, make it inactive, and see then how it affects development, learning, and, your research questions. And then other types of animals or invertebrates that are used in research to just test how they are interacting to their environment, or various types of research questions. Bees, sea slugs, flies, flatworms, these all have simple nervous systems that can be used to test specific hypotheses. And so after this section, I actually have a quick question. And because this chapter is short.